All right. Hi, everyone. This is Carol Woodbury, and this is the first in a series of 6 sessions that Health Systems is providing for you to get started with IBM iSecurity. And so the first one that we're doing is on system values, and there are others, 5 others in the series. So let's just go ahead and get started here. Okay. So and a couple housekeeping items. The handouts will be available after the session. You will get a link to the recording along with the handouts. So you do not need to ask if you can get the handouts. They will be sent to you. And if you have any questions, go ahead and put them in the Q&A box, but I will not be answering those until the end of the session. All right, so let's get started. When we look at IBM iSecurity, the way that I like to describe it is that it's a bit like a 3-legged stool. So a stool that has 3 legs on it. And if you have all of those legs be the same length, then everything is in balance. And that's how you have to have your security on your IBM i, or something will be out of balance. In other words, your policy, the way that you want it to be, will not actually be enforced because perhaps all of your users have too many privileges or your objects aren't secured. So you have to have it in balance. So the first thing that I look at when I'm looking at the balance of IBM iSecurity are system values. The other 2 areas, and those will be covered in other sessions, are user profile configuration and object authorities, okay? So again, those will be covered in other sessions, but today we're going to look at those global settings, which are system values. All right, the first one that you have to pay attention to, and the most important one on the system, is the security value called Q security. And that is the one that sets the tone of security across the entire system. So there used to be 5 values for the Q security system value: level 10, 20, 30, 40, 50. Level 10 went by the wayside a very long time ago while I was still at IBM. And even then, it was early in my career as IBM team leader that we got rid of level 10. Right now, there are 4 levels of security: 20, 30, 40, 50. The problem with level 20 is that when you sign on, by default, you have all special authorities. Okay? Level 30, when you create a user profile, it no longer has all special authorities. By default, profiles have to have authority from some other place. So let me back up. The problem with level 20 is that when you create a user profile, the system by default gives all object. Okay, that's fine, except that everybody has all object. And in this day and age, we can't have all of our profiles have all object. So the next level up is called object level security. And the reason it's called object level security is because when you create a user profile, by default, the system doesn't give it all object anymore. So when you go to access an object, say you go to access a file, open a file, the user has to have authority to open that file. And so it's not going to come by default anymore from all objects, so it has to come from someplace else. So that's why it's called object level security. The next level up is level 40, and at level 40, that's where you get operating system integrity. So you can see in the scheme of things, there's a big leap from level 30 to level 40 in the benefits that you get. So at level 40, you can no longer directly access data in a database file. For example, you can't resolve a pointer to a file and just directly manipulate it. At level 40 and at level 50, you must go through approved interfaces, and those are APIs or commands. Now, the reason this is important is for operating system integrity, as I said. Nobody can replace an operating system program at level 40 and replace it with one of their own, or they can't just directly bypass some of the authority checking or the auditing that goes on at level 40 and 50. So there's quite a difference between 30 and 40. And the system has shipped at level 40 for quite a number of years. The difference between 40 and 50 is not very much. There used to be a bigger difference, but a lot of the features that were only in 50 got moved into 40. So there's not a whole lot of difference. It's primarily how some internal objects are used and some internal programming works. So from an end user perspective, it's very, very, very rare that you would ever see any difference between 40 and 50. It's really more internally processing. If you want to know the exact differences between all of these levels, the IBM Security Reference Manual lists those out. Okay, so since we have talked about the various levels and that you really want to be at level 40, because you really cannot assure the confidentiality of your data or operating system integrity unless you're at 40 or 50. Say your system is at level 30. Well, that move these days is usually pretty easy. To be able to know if you can successfully move to level 40 without any errors, you need to add program fail and authority fail to the Q odd level system value. That will ensure that if there are going to be any issues at level 40, that they can be detected before you go there. So once you have turned that on and let things run for a while, and when I say for a while, I mean especially over a month end, or if you have a quarter end that's coming up that has different processing, you would want to run it over that, just so that you know that the majority of your code has been exercised. Then you go and you look in the audit journal for AF entries, and these are the subtypes that you then look for. Note that you do not care about actual authority failures. The same authority checking algorithm runs at all of the various levels, not just, there's no difference between 20 and 30 and 40 and 50. The same algorithm applies. So it's not authority issues that you're looking for. What you're looking for are instances where programs may be directly calling an operating system program, for example, or directly accessing an object. And while it throws an exception in the audit journal at level 20 and 30, at level 40 and 50, the program will actually fail. So those are the types of failures that you're looking for if you're at level 30. Now, if you're moving from level 20, it's a bigger task. And that's because you have to look for those failures between, or what might happen between 30 and 40, so the previous slide. But remember I said that at level 20, all of your users are by default being created with all object special authority. When you move off of level 20, so when you change the system value, the Q security system value from 20 to something else, when the IPL occurs, because to take effect, you must IPL to get the new value to take effect for the system value. When that IPL occurs off of level 20, the system will strip off that all object special authority for any profile that is not in the SecOff or user class. So you are going to have to determine how your users are going to get authority to your application objects going forward once you make that move. So there's a variety of ways to do that. We'll talk more about where authority can come from when, I believe it's the last session, and I think it might be the first week of September when we talk about object level security. But moving from 20 to 40 is certainly a far greater leap than level 30 to 40. Now, again, I said the good news is that the same authority checking algorithm runs at all levels, so you can actually test out your authority scheme at level 20 simply by removing that all object from some test users before you actually IPL and make that move. So bad news, it's harder, it's more work. Good news is that you can actually do a pretty good job of testing it out before you actually have to do that IPL. Okay, moving on to a different set of system values. So we set the tone of security with the Q security system value, but now we're starting to look at some password system values. So these are all of the ones that begin with the letters Q, P, W, D. So if you want to get the whole list, of course, all you have to do is say work sysval Q, P, W, D star, and you get the entire list. So a couple of the ones that came in somewhat recently are highlighted there with the orange, what are those things? Arrows. That's what those are called. The first one, a password change block, it takes a value, and it's a value in hours. And so you could say something like 24, and that will prevent your end users from using the change password command for 24 hours. So say they have to change it on Monday, they would not be able to change it until Tuesday. And the reason that's there is to prevent users from changing their passwords multiple times and getting back to the same password that they know and love and want to use all the time. That's what that's about. You can also change the number of days that you get a warning that your password is about to expire. But the one I really want to spend some time on is this one called password rules. So in this next slide, I'm showing all of the values that are there for password rules. And I like to point this out because I've heard from, in working with a number of clients, that there's a perception that IBM I cannot match the network security rules or the network password rules that are out there. And that's really not true if you're using the password rules system value. So this provides quite a wide variety of rules that you can apply to your passwords. So I've highlighted a couple of them. You can actually say digit min X, so meaning you can require 2 digits or 3 digits if you want to. You can also do things like limit the profile name. So if my profile was called Carol, I cannot have Carol as any part of my password. So then you can do things like require any 3, which becomes more meaningful once you get into the higher password levels, which we'll talk about in the next slide. But again, I don't want you to think that IBM I can't match those rules, because once you start using password rules system value, you can usually do a pretty good job of matching your network rules. Okay, so a couple things here. There's a new thing that came in, a new value that came available in V7R2 called all create and change. So that, if you think about when you use the create user profile command or change user profile command, you can put in any value for the password. Doesn't matter, doesn't have to follow the rules. Until V7R2, and you say all create and change and put that in the password rule system value. When that happens, that means that even if you are specifying a password on the create user profile or change user profile command, it must follow the rules in the password rules system value. So that has become very powerful, and if you combine that with the value of limit profile name, that now ensures that you will not have a default password on the system. Because remember what limit profile name means. It means that the profile name cannot be any part of the password. And so that the combination of those two will ensure that you cannot have a profile with a default password. If you try to create a profile and leave it as a default password, the profile will not create. So again, very powerful. The other thing that you have to remember about the system value is that you have to have all of your rules in the system value, meaning all of your composition rules. So you can't have your minimum length be that previous QPWD min length system value and have everything else in here. That minimum length, old system value, will be ignored. So once you put one rule in here, they all have to come in here. So that's the thing to remember. Now, password best practices. There's a lot of debate around passwords. Should they be required to be changed? Should they not? But there's a lot of regulations out there that do require password changes. So if you're going to require a password, and if you're not doing something like single sign-on that gets rid of passwords, then the password length should be at least 8 characters. Best practices says that if you can get 16 or greater, then you're going to have all of the password cracking attempts are going to be significantly longer, and so that's what you want to strive for. Passwords should contain a number. They should be changed regularly every 60 to 90 days. They can be overridden. That frequency can be overridden in the user profile. That is most often done for service accounts. That should absolutely not be done for end users or for any administrators, okay? Passwords should also not be shared. Obviously, you don't want to have multiple people signing on with the same profile because your accountability is lost. And the other thing is don't make creating a password so difficult that the users are forced to write it down. And that brings up the point of the password level. Okay, password level, I'm going to jump to 2 and 3. Password level 2 and 3 enables what's called passphrases. And it's often thought that those are easier to remember than a cryptic short password, because a passphrase is often a sentence or a set of words. So it's often easier to remember. Password level 2 and 3 enable the entire character set, so upper and lower case, any punctuation, any special characters, spaces, you name it, it can be in those 2 passwords. So that is really the goal that you should be striving for, is to be able to get to password level 2 or 3. So let me back up. The system ships and the default setting is password level 0. At password level 0, you're restricted to uppercase A through Z, or Z for our friends in Canada, 0 through 9, and just 4 or 5, 4, I guess it is, special characters, $, at, pound, and underscore. The maximum length that you can have is 10. Okay, so the problem with level 0 is that it retains a version of the password that has been encrypted using a very weakly encrypted, old, no longer used Microsoft algorithm. It was used so that you can connect to your net server, the IFS, using a file share. So here's the thing. If you no longer use Windows 95, 98, ME, or Windows 2000 Server, or you don't connect at all to the IFS, then there's no reason for you to be sitting at password level 0. It is very safe to go to password level 1. Password level 1 will get rid of that very weakly encrypted version of the password, and so that will no longer be an exposure for you. So again, the criteria is if you are no longer using Windows 95, 98, ME, or Windows 2000 Server. If you're not using that, it is safe to go to password level 1. It does require an IPL to take effect. The next level up is password level 2. That is kind of a stepping stone to the ultimate, which is really where you want to be, which is level 3. Level 2 introduces that mixed case, and again, all of those special characters and punctuation. Problem with level 2 is that it reintroduces that old weakly encrypted version of the password. And so again, what you ultimately want to get to is 3. The problem is if you ultimately want to get to 3, you probably want to get to 2 first, because it's very difficult to go backwards from level 3. So it's recommended that you go to 2, let it hang there for a little bit, and then go to 3, and that's your ultimate. Again, it takes an ITL to get through all of these levels, so that's a consideration to make. There's more considerations before changing if you look in the IBMI Security Reference Manual. Okay, so moving on to some other types of system values. There are system values that allow you to control sign-on. So the QMAX sign is the system value that says how many times you allow somebody to remember their password after they changed it before they went on vacation. And when they can't remember it, which is usually the case with me, what happens? You either disable the profile or do you disable the device and the profile? You always want to disable the profile for sure. If you are using virtual devices and not named devices, it doesn't make a lot of sense to disable the device because they're just going to get one back for themselves, so those virtual devices. But if you are using named devices, then disabling the profile and the device may be the preferred route you want to take. Then there's a couple others kind of display things that allow you to know the last time that you were signed in. Typically, usually only do that at the user profile level for powerful profiles. Since end users look at that and say, I have no idea why you were telling me the last time they signed in. They just don't know what to do with that information. So I typically override that at the user profile level. That's the display sign-on information. Okay, then the next one is interactive jobs, or system values that pertain to interactive jobs. And these are the timeout values. The recommended setting is 15 minutes. So that means if somebody goes off to lunch and they have not signed off their IBMI session, it would automatically sign them off. And you have 2 options. You can either disable the session, which basically signs them off but still presents that sign-on screen, and then they can sign back on and be back to where they were, or you can actually end the job. Now, a lot of times, organizations have a really hard time with this set of system values, and that's because if somebody goes to lunch and, again, they're 2 steps into a 5-step process, it is often very disruptive to that process to be canceled or have that job ended. In fact, a lot of times people have to go back into those files and kind of undo what has been done. So a lot of times people will instead put a group policy on at the network level to actually time out the entire device. And so I've just put a little bit of a risk assessment, so a risk acceptance statement, I should say, because a lot of times auditors are going to be looking at those system values and say, hey, you're not timing this out. So if you write a risk acceptance statement to say that you are timing out at the network, all of the auditors that I've talked to will allow that to occur. There are definite PCI requirements here. PCI requires a timeout of every 15 minutes. So again, if you can't handle that from an application perspective, suggest that you put that group policy on and leave those system values at the default settings. Okay, then there's some system values that take effect, but only take effect when an object is being restored. So there's 3 of them, and they're actually checked in this order when an object is being restored. So the first one that the system looks at, say we're restoring a program object. So if the program object is being restored and the program has been digitally signed, then the first verify object restore system value says that if it is valid, the recommended setting of 3 says if the object has been digitally signed, that signature must be valid. Now, to me, that's a very reasonable thing to say because if somebody has taken the time to sign an object, I do want it to be a valid signature. So that's what that does. Now, the vast majority of objects aren't signed. The operating system is signed. Don't know if you knew that, but the whole of IBMI operating system is digitally signed. So this, again, is kind of a protection mechanism for restoring things like PTFs. When you're applying PTFs for the operating system, it would validate that operating system signature. Okay, the next one is force conversion and restore. And again, the recommended setting of 3 says, if the operating system thinks the object has been tampered with, then reconvert it. So what could happen? In a program object, somebody may insert a machine instruction that only the operating system or only IBM should be allowed to run and create programs that run this machine instruction. So if somebody has attempted to do that and then restores that object, the operating system is going to detect that it has been tampered with, and that program would not be able to run. The next one is that it looks at the allow object restore system value. So this basically says it's yet a third control as to what comes onto the system. So you can actually say, I don't want any system state objects. Those should be only operating system programs to come onto the system or programs that adopt. There's a few values that you can use to control. Basically, if you say *none for this, then you're not going to allow much to be restored onto the system. So practically speaking, you'll want to specify allow PTF on there, and if your application security model uses adopted authority, you'll probably also have to have allow program adopt for this value. Okay. The next set of system values are configuration system values. The first one is auto-config, and that only pertains to hardware devices. So if you're plugging in a new program object, and it used to be for those hardwired devices. Those hardware devices have really gone by the wayside now, and so that's controlled by auto-vert. So that's where you get those QPADEV devices. That comes under the heading of auto-vert. The recommended setting is to turn off auto-config unless you're actually adding new hardware. And for the virtual devices, don't set it to nomax, so your system gets filled with virtual devices, but set it to a number or to 0. If you set it to 0, the virtual devices are not deleted, but no more can be created than what have already been created. The next one is QCreateAuth. So this system value sets the default value for public authority when any object is created. So if you change this value, it doesn't affect existing objects, just the values of the objects going forward. And we'll talk more about public authority and, again, the whole object authority thing in the last session, and it's the object authority session in September. If you choose to change this value, you're going to want to do some research before you do that. Number one, again, it has no effect on existing objects. It's just the objects going forward. And there are some libraries that you will not want to touch. If you look at IBM libraries, they have already done some modification to their libraries. So again, let me back up. The QCreateAuth system value, actually let me move forward one and then I'll come back to this. So in this chart, it really shows the progression of where public authority comes from. Public authority is set when you initially create an object. So say we're creating a data area. If you prompt the create data area command, you'll see this value called AUT. That's really the public authority setting. So I could say something like *use right when I created that data area. But if I just let it default, it's going to point to this value. It defaults to this thing called live createauth, which is pointing to this value called create authority in the library that I'm creating this data area into. Well, the default value for create authority is sysval. What does that mean? Well, it points to QCreateAuth. And by default, the system ships with this system value set to change. That's how the vast majority of the objects on the system get set to public *change. Now again, you can change this at the system value level. You can also change it at the library level. So now let me back up, backwards. Okay, so when you go, if you decide to change the QCreate.system value, you will want to take a look at some of the libraries in the system. So say that you're going to set QCreate to exclude, for example. IBM libraries have already had their value overridden. So they are assuming a value, in some cases used, in some cases changed. You do not want to change those values for the IBM libraries, okay? Leave those alone. You also want to think about vendor libraries. So if there are vendor products, like one of the products from Help Systems, for example, that have been tested where QCreate is changed, you may not know what's going to happen to that vendor product if you change the QCreate value to exclude, for example. Don't know what robot would do with that. So you might want to change the robot libraries or the network security libraries or the policy minder libraries back to the original setting, okay? So override those back to change. Then you have to take a look at your application libraries, and those are the ones you typically want to be affecting, right, what is your application, because that's where your data is. And also query libraries usually have some considerations too. So don't just blindly go and change this QCreate.system value without thinking through the ramifications and the realization that you can affect the change at multiple levels. Okay, then there's one called QUseAdopted Authority, kind of a strange system value, but it controls the people that can compile a program that uses adopted authority. Not that adopts authority, but uses adopted authority. So remember, and again, adopted authority we'll talk about in more detail in the object level session, but adopted authority is stack-based. So once the program starts to adopt, if it remains in the stack, all subsequent programs can use that adopted authority. If for some reason you don't want it to use adopted authority, you can control who can create the programs that say to use adopted authority by using this system value. It's very rarely used, but it's out there. Okay. Of much more importance than the QUseAdopted Authority system value are these SSL system values. And truthfully, when these first came out, these were, we pretty much ignored them. The security team pretty much ignored them. They really didn't have a whole lot of bearing. But in the last few years, we have definitely stepped up our game on this one and started to pay very close attention to these system values for our customers. And the reason is because of the vulnerabilities that have been exposed with the protocol called SSL. So plus there's a renewed emphasis on making sure that all communications, even internal communications, are encrypted. So if you're going to encrypt those sessions, that needs to be done with a strong protocol. Also, PCI has a requirement that only what is called strong encryption or TLS 1.1 and 1.2 are used as of next July. So there are 3 system values that can control the protocols that are available on the system and then the actual encryption or cipher suites that are available once that connection is made. So the system value that controls the protocols is the one that ends in PCO, protocol list. Your options, I'll show that to you in a minute. And then there's 2 others that allow you to control what ciphers or what actual encryption algorithms are available. If we look by release, again, remember I was saying that PCI requires that you use only TLS 1.1 and 1.2 by next summer. So you have to be on R1 with technology refresh 6 or later to even be able to have TLS 1.1 and 1.2. Now, they're there by default in 7.1 and 7.3, so it becomes easier at those 2 releases to have stronger encryption. And this is a list of the encryption algorithms that are available when you are making these secure communications. Now, you can just tell by the length of the list, and if you know anything about encryption, the type of ciphers that are available. The elliptical curve comes in V7R2 and R3. The more recent the release, the stronger encryption you have available to you. That's another reason that as you move off and migrate off of 7.1, that you highly consider going straight to V7R3 because of the strength of the encryption that you have available at that version, even over V7R2. Now, if you are totally unfamiliar with encryption capabilities that are on the system and totally unfamiliar with needing to stop using SSL and move to TLS, we did another one of these sessions. We call them Coffee with Carol. And there's a webinar that I did very specifically about these set of system values. So I encourage you to go and listen to that if you need more information. Okay, there's another set of system values, and those are the QScan system values. Now, those were originally developed so that we can do real-time virus scanning in the IFS. And yes, the IFS can be affected with malware. And so that session is also going to be discussed. IFS security is going to be discussed as one of these six sessions. And so there will be more detail on that later. But know that these scan system values were there to provide us with the capability of having real-time virus scanning. So you can, when you open a file, you can scan it, or before you write it to disk, you can scan it. So between these system values and the exit programs that are registered to these exit points, that's how you get real-time virus scanning. So that was a discussion on the security relevant system values. There are a lot of system values, but I tried to focus today just on the security relevant ones. Now, one feature I haven't talked about is the ability to lock those system values. So what do I mean by that? I mean to be able to make it so that they cannot be changed by somebody doing a work sysval and taking an option 2 to change it, or having a program come in and change it, or a vendor change it before they install something. So IBM has provided the ability to lock those system values and not allow them to be changed from their current setting. So if you want to do that, you go into System Service Tools or Dedicated Service Tools, DST, and these are the system values that can be locked. Now, the thing that you have to remember is that it's not that you can pick and choose which ones to lock. It's an all or nothing. So you lock all of these and prevent them from being changed, or you don't. So just understand that limitation. So the way that you go into, this is the sign-on, or this is the method through SST. You go in, you choose option 7. You'll get the option to allow system security value changes. You would change that from a 1 to a 2, meaning no, and now they're locked. So if they need to be changed, you would have to go back into Service Tools and set this back to a 1, and then they can be changed. So it's just a good protection mechanism for allowing system values to be changed or not. So a lot of times I get asked, well, how do I know what the best practices are for system values? So our Risk Assessor product provides a comparison on your system when you run the product. And if you would choose to either subscribe to our managed security services and do a risk assessment there, or just have a standalone risk assessment, one of the things we do is compare your system value settings to security best practices. So what we've done is look at a variety of places, ISO standards, NIST, COBIT, and regulations like PCI, and then we take those, translate them into what they mean for IBMI, and compare current settings with security best practices. So you get that comparison there. Also, there's some guidance in the IBM Security Reference Manual in Chapter 2 and 3 for these system values.
So with that, we wish everybody a great day, and if you need more help with security, we do offer professional security services. You see the link on the screen there. Happy to